and welcome to this video where we get to learn the basics about counting fast when balancing chemical equations. My name is David, and on this channel all we do is break down the concepts of chemistry into simple bits and pieces that you can understand. So let's get into what we have for this video. So one major reason students struggle with balancing chemical equations is not actually balancing, it's the counting aspect. Okay? The truth is, if your counting is wrong, then automatically your balancing will also be wrong because your balancing depends on your counting. Your balancing depends on your counting. So the skill of knowing how to count properly in the process of balancing chemical equations is key. So let's look at this chemical equation for instance. The first thing we want to do is count, adjust, and then recount. That's our CaO method. Count, adjust, and then recount. So we have one column for the element, and then we have another one for the left hand side, and then we have another one for the right hand side. So let's write out the elements. For the first one we have calcium. Okay, allow me to identify the elements for you. You can see we have calcium Ca, we have carbon C, and we have oxygen O. Calcium, carbon, and oxygen. So on the left hand side, how many atoms of calcium do we have? On the left hand side you can see CaCO₃. Calcium has just one atom present. Write that down. How about on the right hand side? You can see calcium also appears here once. Now let's move to carbon. How many atoms of carbon do we have? You can see carbon appearing here once as well. And on the right hand side, carbon also appears once. How about for oxygen? On the left hand side, you can see oxygen having a subscript of 3. So oxygen appears thrice. On the right hand side, you can see one atom of oxygen, and over here 2 atoms. That gives us 1 plus 2, which yields 3 atoms. So altogether this equation is fully balanced because all elements are equal on both sides. So you see how important the skill of counting is in the process of balancing chemical equations. It is that skill that helps us to know if a chemical equation is balanced or not. Now if I were to ask you, how do you know the number of atoms present in a compound? Well, it's super easy. We have the first example, CaOH2. This is called calcium hydroxide. The first thing to do would be to identify the elements. We have calcium, we have oxygen, and we have hydrogen. So how many elements or how many atoms of calcium do we have? Calcium appears just once here. Let's write that down. Oxygen appears how many times? Now, notice something. There is a bracket or something called a parenthesis. In science, it is also called a parenthesis. A parenthesis. Now this bracket simply means that whatever the number it is that stands outside of it affects everything that's inside the bracket. The number standing outside is this number 2, so it means it affects both this hydrogen and affects the oxygen as well. So oxygen automatically becomes 2 atoms, as well as hydrogen, it also becomes 2 atoms present. So that's the number of atoms of each element that are present. How about for the second compound? We have Al2 SO4 So we have 3 elements: aluminium, we have sulfur, and then we have oxygen. How many atoms of aluminium do we have? You can see a subscript of 2 which belongs to aluminium, telling us that there are 2 atoms of aluminium present. How about for sulfur? How many atoms of sulfur do we have? We have solve for in this bracket or the parentheses. Now there is a subscript of 3 standing outside it, which means 3 affects this solve for. So there are 3 atoms. How about for oxygen? Now you can see oxygen has its personal suffix of 4, and there is something standing outside which is 3. That means this 3 multiplies this 4 to give us 12 atoms. So these are the steps that you take when you want to count the atoms that are present in a chemical equation or in a compound. Now we have this exercise on the screen that says count all the atoms in this equation. So how do we do that? Well, the first thing to do would be to write out our table. We have one column for the elements, we have another column for the left hand side, and we have the third one for the right hand side. Well, the elements we have are aluminium, and then we have chlorine. So for aluminium, on the left hand side you can see aluminium over here with a coefficient of 2, and on the right hand side aluminium also has a coefficient of 2. So aluminium has 2 atoms apiece, both on the left and on the right. How about for chlorine? You can see chlorine Cl2 with a coefficient of 3. So that 3 multiplies these 2 to yield 6 atoms on the left. How about on the right? Well, on the right we have chlorine inside this compound, 2AlCl3. This coefficient of 2 also affects this 3, which gives us 6 atoms. 2 times 3 gives us 6. So we have 6 on both sides. So the counting skill has showed us that this chemical equation is balanced because all elements are equal on both sides. Now at this point someone might be asking, what is the best place to begin when you want to balance a chemical equation? Well, the best place to begin is to start with the elements that appear only once on each side of the chemical equation. Usually leave oxygen and hydrogen for later. This simple trick that I just gave to you will reduce plenty of stress for you. It will reduce plenty of stress for you, I assure you. Leave oxygen and hydrogen for later. Now you might be asking why. Well, the truth is oxygen appears in many compounds. You'd find oxygen in water, you'd find oxygen in carbon dioxide, you'd find oxygen in calcium carbonate, you'd find oxygen in sodium hydroxide, you'd find oxygen in so many compounds. So because of that, its numbers keep changing when you are balancing other elements. It's quite a stubborn one to get along with, so you leave oxygen for later. Let me give you an example to buttress what I just said. We have this equation on the screen. How do we balance it? Well, let's do that very quickly. The first thing to do would be to use our CAR method, CAR. C stands for count, A stands for adjust, and R stands for recount. So we have one column for the element, we have another column for the left hand side, and the last one for the right hand side. So let's identify the elements that are present. We have iron, Fe. Let's write that down, iron. And then we also have oxygen, oxygen O. The next thing to do would be to count. How many atoms of iron do I have on the left hand side? On the left hand side I have just one atom of iron, so I write that down. On the right hand side, how many do I have? I have 2 atoms. I write that down because of this subscript of 2. How about for oxygen? On the left hand side I have 2 atoms of oxygen, that's it over here, and on the right hand side I have 3 atoms of oxygen. I've written that down. Now we can see that the equation basically is not balanced because on both sides the elements are not the same in terms of the number of atoms present. So remember I said we leave oxygen for later. So that automatically means we begin with iron. I have 1 on the left and 2 on the right. So to balance iron, I simply put a coefficient of 2 over here to take the left hand side from 1 all the way to 2. Did you see how that was done? So now I have changed the coefficient for iron. I need to check out the next thing to work on, which is oxygen. Now you can see oxygen over here having a coefficient, or a subscript rather, of 2, and then there is a subscript of 3 over here. So oxygen has 2 atoms on the left hand side and 3 atoms on the right hand side. So how do I balance oxygen? Well, if I decide to put a coefficient of 2 in front of oxygen over here, it then means oxygen will become 4 atoms. But that will not be the same with this other side here. So I can't put a coefficient of 2. But if I put a coefficient of 3, it means oxygen becomes 6. And this other side remains 3. So what do I do? Well, there is something I will do. It's called creative multiplication. I will use a number to multiply the left hand side over here and use another number to multiply the right hand side over here to make both sides become equal. So here is what I mean. On the left hand side I have O2, on the right hand side I have O3. I want to make these two guys to be equal. I can multiply this guy by 3, therefore I have 6 atoms of oxygen, and then I come here and multiply this guy by 2, therefore I have 6 atoms of oxygen. So that therefore means that I now have a coefficient of 3 on the left side for oxygen and 2 on the right side for this compound Fe₂O₃. Can you see how that was done? Now that way I have 6 atoms of oxygen on the left and 6 atoms of oxygen on the right. So the left side moves from 2 to 6, the right side also moves from 2 to 6. Can you see the steps I'm taking? At this point I have changed the coefficients again. I need to count the number of atoms for each element that are present on both sides. So for iron I have 2 atoms on the left. On the right you can see a coefficient of 2 affecting the subscript of 2 for iron. That makes it 4. So iron is now 4 on the right. So that means I need to balance iron again. To balance iron, it means that I'd have to change this coefficient from 2 all the way to 4. So therefore this is what the equation will now look like. Allow me to create some space so I have where to write on. So this is what the equation now looks like. I have 4Fe plus 3O2 yielding 2Fe₂O₃. This, my friends, is the final balanced equation. Now let's count the number of atoms for each element that are present. For iron, I have 4 on the left, and on the right I have 4. For oxygen, I have 6 on the left, and on the right I have 6. The equation is fully balanced. If you're getting massive value for this, consider liking, sharing, subscribing to this channel for more amazing content coming your way every single day of the week. The next equation we have on the screen is this one over here. So what do? First thing to do would be we use our CaO method: count, adjust, and recount. Count, adjust, and recount. So the first column is for the element, the second one is for the left hand side, the third one is for the right hand side. So how many elements can I identify? I have carbon, I have hydrogen, and I have oxygen. So let's write them out. Carbon, hydrogen, and oxygen. The next thing to do would be to count the number of atoms for each element on both sides. For carbon on the left side, I have 3 atoms. You can see it over here. And on the right side, I have just 1 atom. For hydrogen on the left side, I have 8 atoms by this subscript. On the right hand side, I have 2. And for oxygen, I have 2 on the left, and on the right side you can see oxygen appears here and also appears here. Over here it has 2 atoms and over here it has 1. So altogether we have 2 plus 1, which gives us 3 atoms. So the equation is not balanced. Well, the first thing to do would be to remember that I said that we leave oxygen and hydrogen for later. So that means we begin with carbon. So to balance carbon, I just simply introduce a coefficient of 3 to the right hand side. So the equation now becomes C₃H₈ plus O₂. Then we have 3CO₂ plus H2O. That way, carbon is now balanced. It moves from 1 to become 3. 3 on both sides. Now I have balanced carbon. The next thing to move on would be to move on to hydrogen. Alright, so now that we have balanced carbon, the next element to balance will be hydrogen. On the left hand side we have 8 atoms and on the right hand side we have just 2. So to balance hydrogen we introduce a coefficient of 4 over here to multiply these 2 to make it to become 8. So it moves from 2 to become 8. And then finally we move to the last one, which is oxygen. On the left hand side we have 2. On the right hand side, oxygen appears here having a subscript of 2 and a coefficient of 3. That makes 6. And over here there is a coefficient of 4. That makes 4. 6 plus 4 gives 10. And on the left side there is just 2. So we introduce a coefficient of 5 to balance it fully. So altogether we have C₃H₈ plus 5O₂, yielding 3CO₂ plus 4H2O. This is the final and full chemical equation. I hope you got value for this. So here are some quick practice questions I'd like you to try out your hands on. Which element should you start with first in this chemical equation? Balance it and let me see your answers in the comments, and then handle this one as well. I look forward to seeing you in the next video where we get to see polyatomic ions in chemical equations. It's been David, and I look forward to seeing you in the next one. Up until then, stay blessed.